Okay, today's topic is points, lines, intervals, and angles. We're kind of starting a new sort of a section related to geometry. And as you know, mathematics is essentially its own language. And as a result of that, it has its own vocabulary, which we typically talk about, we typically call terminology. So today, we're going to talk about a number of terms. You need to write all these down if you have time. If you want to pause first and write them down, that's fine. But I'm going to go through and talk about each one of them. The first is a point. A point is just a single spot in space. We think of it as having no dimension, no width or length or height or anything like that. And we typically refer to points with capital letters, maybe A or something like that. A line is defined by 2 points at least. Let's say those 2 points are A and B. And a line goes through points, pretend that's straight, and it goes on infinitely in both directions. Okay, it goes infinitely in both directions, and we name it with 2 points, and we could refer to that as line AB or line BA. A plane goes in every direction, but it's a flat surface. So if you thought of this whiteboard as extending infinitely that way, that way, that way, and that way, that would be a plane. Or if you thought about the floor and you knocked out the walls and thought about the floor as going forever that way, that way, that way, and that way, then that would be a plane. Okay? Planes, of course, they don't have to be straight up and down. It could be a plane in this direction or whatever like that. That's a plane. Now, one way to think about this is that points have no dimension. Lines have 1 dimension. They go all the way one way or the other. They're one-dimensional. Planes are 2-dimensional, so they're flat, like a table. Okay? We can also talk about space, which is 3-dimensional, but we'll save that for another time. When we talk about points that are collinear, co meaning together, it means they're on the same line. So if we have a line, and then we talk about points A, B, C, and D, and they're all on that line, then they are collinear. That's what collinear means. An intersection point happens when we have 2 lines that cross each other. Intersect just means to cross or meet. So if we have 2 lines and they intersect, then that is referred to as the intersection point. Maybe it's point D. That's our intersection. When we talk about concurrent lines, it's related to intersection, but instead of 2 lines, we're talking about 3 or more lines. Something more than 2. If we have more than 2 lines that intersect all in the same point, perhaps it's point J, then we say that those lines are concurrent. They all intersect in the same point. We can also talk about, rather than lines, we can talk about pieces of lines. Remember, lines go infinitely in both directions. If we wanted just a part of a line, let's say we wanted just this piece right here, we called it C and D, we could say interval CD or segment CD or DC, segment DC or interval DC. We can also talk about parallel lines, so lines that run beside each other and never meet. Those are called parallel lines. And there's a couple of things that you need to know about them. Let's say that we have line AB and line CD. And we want to say that those lines are parallel. We would say AB is parallel, have 2 lines like that, to CD. That's what that notation means. The other thing that's important in the notation is that we say this. We put a little arrow on this and a little arrow on that in the middle of the line somewhere, and that tells us that those 2 lines are parallel. The other thing that lines can do, they can be parallel, they can just intersect generally, or they can intersect at a right angle, 90-degree angle, like the corner of a page. So if we have those, then we call them perpendicular lines. That means, let's say we have AB and another line CD, we would say those lines are perpendicular because they meet at a right angle. The notation for this would be AB, and we use a little upside down T, which means is perpendicular to CD. And on our chart or our drawing, we put a little box in the corner at the intersection, and that tells us that it's a 90-degree intersection. 90 degrees, they are perpendicular to each other. Now we also have angles. There's some terminology that goes with angles. And those start out with a ray. A ray is like half of a line. It starts at a single point and goes infinitely in one direction. So for example, we have A and we have B. We could say that that is ray AB. Okay, that's ray AB. Starts here and goes infinitely that direction. When we take two rays and put them together, let's say they start here and they have the same point that they start at. And let's say we have A and B and C. Then we have a ray here and a ray here. They both start at the same place. We call that point the vertex. That's where the two rays are. You might say it's the point, because what have we made? We formed an angle. Okay? Formed an angle, and the point of the angle is the vertex. The two rays that make up the angle, they're called arms. Together, two rays meeting at the same vertex make up an angle. Now, two things about that angle in terms of the notation that we talk about. The first is that we name the angle with the three letters, the three capital letters. It is important the vertex must be in the middle when we do that. The vertex must be in the middle. So for example, if we wanted to name this angle, we would say angle BAC. We could also use, in this case, angle CAB. Notice that the A is in the middle of both of those. This, angle ABC, that would not be acceptable because A has to be in the middle. And finally, the last thing in regard to this is that angle has a measurement, as you know. That one may be something like 40 degrees. I'm not very good at guessing, but let's say it's 40 degrees. But we don't actually know what it is. So whenever we're talking about the size of an angle that's unknown, we typically mark that with a small letter rather than, so we say A degrees, we use a small letter rather than capitals. Now, one more thing that we need to talk about in terms of the notation of this, and I'm going to erase a couple of these. If you don't have everything that's up here written in your book, you might want to pause the video at this point so you can do that, because I'm going to erase a little bit of this. The other notation thing that is very important for us is how we mark some diagrams. So let's say, for example, that we had a figure that looked like this, and we had a mark like this, these. Okay, when we have a diagram like this, the fact that we have a hash mark on these two lines tells us that those two lines, or line segments actually, that those two line segments are the same length. That's what the little hash mark means. There are two hash marks here and here, and that tells me that those two lines are also the same length. They're not necessarily the same as these. They could be, but we don't know that yet. Probably not. But we know these two are the same, but different lengths than these two. Similarly with angles, the fact that we put a little loop thing in an angle like that tells me that those are the same. This sort of a thing with two loops also tells me that these two are the same, but probably different from these two. Now we can also do some slightly different notation with the angles, but it means exactly the same thing. Sometimes what we do instead of this is we mark them this way and we say that those two are the same. Again, it's one hash mark just like the sides. Or we might say this, that these are probably different than those, but they are the same as each other. That is the notation that we need for geometry, at least at this point. So you need to get all that down, make sure that you know it and understand it. And that is the terminology of points, lines, intervals, and angles.